How you doing? I'm Jan Manek, Director of Commercial Sales here at One Stop Systems, coming back at you with another virtual trade show. This time it's Flash Memory Summit 2020. Got some pretty cool products to showcase for you today, starting with this product right here. This is our 2U expansion optimized server, which we call the EOS. This is a full Gen 3 or Gen 4 server platform, which can communicate to up to 24 drives across the front of the chassis. So these drives can be SATA, SAS, or NVMe, and exceed capacities of 32 terabytes each. So we're looking at up to 768 terabytes of storage that you can put on the front end. And on the back side, the motherboard platforms now can have up to 7 Gen 4 by 16 slots. So that really gives us a lot of flexibility on what we want to do. In some cases, if we're running PCI Express internally directly to the drives, we can do that using some one-stop Gen 4 switch products here. In this case, we are also showcasing a 100 gigabit NIC connection to the outside world, or an upstream switch. And if you notice here, we have 2 Gen 4 by 16s going over to our Storage Box 2000. So brand new storage product from One Stop Systems, has a very similar 24 drives across the front. These drives are actually removable by drive packs of 8, so you can pull these out, which is very cool and very, very flexible. You can also pull them individually. And it has up to 4 256 gigabit connections of PCI Express back to an upstream server. So up to 1 terabit of PCI Express. Extremely high performance, extremely high capacity, and basically now you're looking at a 4U 1.5 petabyte type of storage appliance. I mentioned the flexibility factor because this EOS can also be used as our 2U ION accelerator. Our traditional ION accelerator, the 5.3, supported SAN and NAS configurations and was a Gen 3 solution. But now that we're in the year of Gen 4, we're also getting into NVMe over Fabrics solution. So the demo that we're actually showing today is exactly this setup. It's a 100 gigabit network connection coming in from the Initiators, connected over 2 by 16s of Gen 4 by 16 PCI Express to our Storage Box 2000, which again can support Gen 4 U.3 NVMe devices across the front. So we're getting really high performance, up to 60 gigabytes per second of performance, and depending on whether it's a single CPU or dual CPU, we can actually get up to 10 million IOPS. So hopefully you guys are around to see that later today, that demo. Thanks again.
Hi, my name is Ranjan Gupta. I will be showing the NVMe over Fabric demo. All right. So I was mentioning we have 4 initiators, R12i2 to R12i5. They're all running Ubuntu 2004 LTS. Out of each initiator, we have a 100 gigabit link going to the switch. And similarly, at the bottom, we have an ION accelerator, which is running our latest software. Traditionally, we have supported SCSI, Target, over InfiniBand, iSCSI, and Fiber Channel. In this latest release, we are adding the NVMe over Fabric functionality, both for RDMA and TCP/IP. And from ION accelerator, you can see there are 4 100 gigabit links going into the switch. That's the topology we have running in our lab. I'm going to go to the next slide. From the ION perspective, these are the steps you have to do to configure ION using the GUI. You log into the GUI using admin, then you configure your storage port, you configure your storage profile. We support various storage profiles from RAID 0, RAID 10, RAID 5, RAID 6. And then you have a host groups. Each initiator, which is like R12, I1, 2, 3, 4, 5, they belong to one host group. And you have to put in your host NQN into that host group. And once you configure your host groups, the last thing you need to do is configure your namespaces, which is basically exporting out the storage from ION to the initiators. So I'm going to walk you through that using the real life system GUI. Give me a second here. I'm going to switch over to. So the first step is go into the system tabs. There are various things you can do in this tab. The first and foremost you have to do is configure your storage ports. As I said, we have 4 storage ports, P20, P1, P2, P1, and P2. They're all using 4 separate subnets from 210, 220, 230, and 240. They're all running at 100 gigabit. You can see the speed here. And the MTU size is configured for 9,000 bytes. And here is the gear tab where you can change things. Since this is a live demo, I'm not going to change anything. I just wanted to show you what are the steps you have to do to configure the ION. So this is the network ports, and there are a few other things in here you can do. Is the default gateway. You can set up your DNS server, set up your time zone, and the NTP server from here. Here is the alert email. You can set up your alert email from this tab. And the last thing here is the SNMP, if you want to set up your SNMP, so the ION will send out all the traps. The last thing is the software. Here you can see what version of the ION software you're running. And the same tab can be used to update your firmware or ION software. I'm not going to do that here. I just wanted to show you this. The next steps are how to configure your storage. Here we have a single pool, pool 1. I've taken all the drives in the system and created a single pool. And this pool is a RAID 0 configured right now, even though it doesn't show right here. If you create a new pool, and here you can see, you can select RAID 0, RAID 10, RAID 5, RAID 6, and JBOD. And the JBOD is by default right now because we only have a single drive, NVMe 16. And that's why it gives you the JBOD profile. If you have more drives, then you can select any one of these profiles. And as I mentioned, we have a single pool, which I've taken all the drives and basically running a RAID 0 profile. The next thing, as I mentioned, we have these host groups. There are host group HG2, which has host R12Y2. And host NQN is this is basically you have to go into the initiator to find the NQN of each initiator. It's very similar to iSCSI system. In iSCSI, we have IQN. In NVMe over Fabric, you have NQNs. So I have configured this setup here. There are 4 host groups. Each has a single initiator in it with its own NQN. The last thing we do in here is, so we have the host groups configured, and we have one single big pool configured. And the next thing is you create namespaces. In here, as you can see, I have created 4 volumes. Each wall 2 is 10 terabyte size, exported to a host group 2. Only host group 2 can access wall 2, and it's from pool 1. And there's several actions you can take from here using this gear tab. From here, you can extend your volume. Here, you can change your access to the volume. Changing access means you can revoke HG2 from this volume, so HG2 cannot see the volume 2, or you can add additional host groups so they can access the same volume. So, or the final one is the delete. You can delete this whole volume. So these are the 4 volumes I have configured on the system for the demo purposes, and I will show you how they're all connected. The next slide, I'm going to go back to my slides. So I covered basically how you configured the GUI, how to use the GUI for NVMe over Fabric. The same GUI can be used your traditional SAN storage, which is a SCSI LUN, which we support InfiniBand, iSCSI, and Fiber Channel, which we are not going to mention as this demo is only for NVMe over Fabric. The next 2 slides, I'm just going to mention that we have an extensive CLI in the ION. You can, all the steps you have taken in the GUI, you can use the CLI to configure your ion. You don't have to use the GUI. I'm going to put it in a presentation mode. Back to the topology, I'm going to show you how the initiators are going to see the ion storage using NVMe over Fabric. So remember in your host group, in the host, we had set up an NQN. And how do you find the NQN? There's a file in each initiator. Every Linux distro has it. You just do a etc NVMe host NQN. It will display the host NQN. To configure your initiator, you have to load these two modules, NVMe RDMA and NVMe TCP. After you have loaded those two modules, you configure your Ethernet ports. It's very standard utility, IP adder, ifconfig, any one of them you can use to configure your links. After you have configured your links, you want to make sure you can communicate with the ion. Use the ping utility to ping, make sure you can ping every port or the port you think you have configured and connected to. And the last two steps are NVMe over Fabric specific. You can discover from the initiator to see, hey, what NVMe storage are available on the network. So NVMe discover is the command to discover all your volume. I'm going to just show you how that works. And once you have discovered it, you have the the storage NQN. And this is where you use this NVMe connect to connect to your storage. You basically get the NQN from this output of this command. So you can connect to any one of the NQN which Ion has exported out. The next slide is, once you have connected your NVMe, these are the steps you can do to make sure you have connected the NVMe. You do an NVMe list. You can do NVMe list subsystem, and you can configure the policy. If you have multiple paths going to the storage, you can set up this policy, whether you want to do a round robin or a minimum if you have multiple CPUs in your initiator. And the last graph is this graph, which I will actually show you live, what all this bar means. And before I do that, I just want to show you the initiator, what they're configured for. So I'm going to take away this slide here. And here is, I can do an NVMe list from my initiator. I have 4 initiators. This is a little script I've written. Basically, it shows you for node 2, I have NVMe 0N1, which is on the Ion side, it's a volume 2. And the size of it is 10 terabyte, which I showed you on the GUI itself. Similarly, Wall 3 is using node 3, Wall 4 is node 4, and Wall 5 is node 5. Back to the live demo here. I'm going to go into the dashboard. This live demo is running, and here you will see 6 graphs. We have first graphs is basically in this thing is the IOPS. It's the read IOP. The blue lines will be the read IOPS. As you can see, we are getting about 2.8 million IOPS. These are read IOPS out of the total system. And the next graph will be the bandwidth. This takes about, there's a 10-second delay here. After 10 seconds, it will go to the bandwidth. I'm going to just wait for a few seconds here. So here is the bandwidth for the read, and basically we're using 64K block size. As you can see, we are getting about 301 gigabit per second out of the storage. And so the blue lines are the read, the next two lines will be the write performance. Similarly, we'll get the IOPS first, and then we'll get the bandwidth. And similar to the read performance, the write performance will be pretty much the same. So there is no difference whether you're doing the read or doing the write. So here we're going to see the IOPS, the write IOPS coming in here. By the way, this from the dashboard, you can also, it shows you the total storage you have on the left and how much have you used. I've used 40 terabyte, which is 4 volumes, 10 terabyte each. And this is the remaining storage you have on your system. Here we go. This is the write IOPS. As you can see, we are going about 3.285 million IOPS, and which translates into 110 gigabit per second. If you take the that number multiplied by 4K, that's the gigabit per second bandwidth being consumed. And the next thing is the next graph will be the bandwidth for the write. Again, that's a 64K block size, and we're using a standard FIO utility, which everybody uses pretty much. We'll wait for about 5 seconds. Here we go. We should get about 200 gigabit per second here. The write's a little bit slower than the read in this thing. We are still tuning. The write performance should go up to the same as the read. There is no difference, at least from the back end. So we haven't tuned it to get up to 300 gigabit per second. So that's still work in progress. And after this read and write performance, we are showing about 50-50, 50% read, 50% write. And we'll get the IOPS first, and then the bandwidth graphs. So another about 5 seconds. We'll see the 50-50 load graphs. Here we go. These are the IOPS, and I'll put the thing so you can see the total. It's about 2.969 right now. Should go up to 3, close to 3. There we go. 3.1 million IOPS. This is a 50% read and 50% write. And on the top, you can see the first number is the read, and the next one is the write. And the blue, again, the blue is the read, and the orange is the write. The next graph will be the bandwidth. Again, for bandwidth, we are using the 64K block size. And we will pretty much exhaust both the Mellanox controller, getting close to 400 gigabit per second theoretical. And I think we are getting close to 337, 338, somewhere around there. Let's see. So here's the 334 gigabit per second out of the two. Actually, we are using only 2 rings because the 2 initiator seems to exhaust all the bandwidth out of the box. So 334 is the 50-50 workload. So this is the basically I showed you the read performance, the write performance, and a 50-50. A typical on an OLTP, you will be 70-30 workload, so the number will improve in that regard because you will get more of the read performance than the write performance. That's all I have as far the demo goes. If anybody has any question I can answer, feel free.
Ranjan, you did keep saying gigabytes, but I think that's gigabits.
That's what I'm saying,
Bandwidth,
gigabit,
which
gigabit per second, not gigabyte.
right, which I think translates to about 40 plus gigabytes per second
Correct.
of IOPS of bandwidth.
So on the read, it's a 300 gigabit per second divided by 8. That will give you the gigabyte, a little over 30. And here is the 200 gigabit on the right. It should increase, by the way. If we are still tuning this performance, it should match the 300 gigabit out of the read. And this is the 334 right now. These are gigabit per second. Any other question?
Thank you, Ranjan. That was impressive performance. Appreciate it.
Thank you.
If you missed any of the beginning part of the demo, we will be posting this in our booth at Flash Memory Summit and sending it out to our followers as well. So stay tuned if you missed the beginning. If there are no more questions, we're going to go ahead and end the demo. Thank you everyone for joining.
Thank you.